Alrighty, welcome back. Third video of the day. This one focuses on looking at graphs of linear equations. The line shown has a slope of 1/2 between point J and point L and between point R and point T. So I'm going to make these a little bit darker just so we can see them. So this is point J down here. Point L is right here. Point R is right here. And point T is right here. Now what you're going to notice when we look down to this question is that they start asking about triangles. So there is also a third point on each of these, which created these triangles. I'm trying to make that a little darker for you. So we have triangle JKL and RST. What I hope you can see, I'm going to put it in yellow or orange, whatever color this is that there's a line right here that goes through some of those points on this triangle. And it asks you which describes the relation, which of the following best describes triangle JKL and triangle RST. They are congruent. Congruent meaning same size, same shape. Well, they are both triangles and they're both right triangles, but we can clearly see that this one is bigger. So that is not true. They are similar. They are similar. And I'm going to prove that to you really quickly. So if we look at how much this goes up. This goes up 1, 2, 3, 4. And it goes over or has a width of 1, 2, 3, 4, 5, 6, 7, 8. Okay. If we look at this smaller triangle, its height increases by 2. And its width is 4. When I go to write those in ratios, so height to width, and I simplify them, height to width, and I simplify, I get 1/2 for both of those. Anytime those ratios come out the same, excuse me, that means those triangles are similar. So we don't even need to go any further. All right, what is the equation of the top line graphed below? So on here we have two different lines. We have this first line down at the bottom with an equation next to it that you're somewhat familiar with. It says y equals mx. Notice it goes through the origin, so it goes through the point 0, 0. What they're wanting to get you to look at is that this distance right here, they're calling it b. What that is doing is that is changing this y-intercept right here. We're no longer at 0. Okay, this line has gone up, but they are parallel. So this part of our equation is not going to change. So y equals mx. What is going to change is they have moved this line up. They have translated it up. And they've translated it up by a distance of b. Since it went up, that means it's increasing. So we're going to add that b on. So if I look down here in my equations, this would be your correct equation right here. If we look down at D, it has a very similar equation. It says y equals mx minus b. That minus b would have dropped your line down. So it would have moved it like down here. That would have been y equals mx minus b. I would have moved it down, not up. Question 3. Right triangle ABC is shown on the graph below. If the point -4y, I'm going to write that out here for us, -4y, lies on the line that goes through the side of triangle, lies on the line that goes through side BC of the triangle, what should the value of y be? So what they're wanting to know is that if we were to extend this line out, So this line BC, if we were to extend it out, I'm going to try and draw it really precisely. I don't have a ruler down here. If we were to extend it out and this new point was to lay on our line, where would it be? So at -4, it's asking what that ordered pair is right there. So is that at -4, 0? No. -4, 0 would be right here. So that's a no. Is it at -4, -1? No, that's not even on our line. Is it at -4, +1? Yes. So that would be your point on your line. So the easiest way to answer that question is just to extend that line out and then see if any of these points make sense. All right, question 4. Again, this is another one of those drawing on the grid things, so I'm going to do it on paper, but you all are going to use the tools that are on your computer. So the graph below shows triangle ABC. Draw a line that goes through the hypotenuse of ABC. Hypotenuse is one of those geometry vocab words that we just are learning with Pythagorean theorem. So we're going to find the right angle in this triangle, which is right here at B. The hypotenuse is opposite of that angle. So they want us to draw a line that connects that point. So I'm going to extend this line out to the best of my ability. There we go. Alrighty. Alright, so there's my line extended out. Draw a line that goes through the hypotenuse. We did that. Now it says construct a similar triangle with the following guidelines. It needs to have side lengths that are exactly twice as large as ABC. So let's find out how big ABC is before we get the rest of our requirements. So A to B has a side length of 3. I'm just counting. So 1, 2, 3. B to C has a side length of 2. So if I want to make a triangle that's the sides are twice as large as that, that means I need a new triangle that has a base of 4, because 2 times 2 is 4, and a height of 6. So I just jotted that up there for our notes. Okay, good with that? Sorry, my chair's rolling away from me. The next thing it tells us is that we have to have the vertex or a point at 0, 4. So I have to have a point right here at 0, 4. The hypotenuse has to have the same slope as the hypotenuse of AC. What that means is that my triangle needs to be on this line right here. I don't want to take a new point and come over here with it, because then that hypotenuse is not going to be on the same line. So what we are going to do is we are literally just going to count over 4 and up 6 to make our new triangle. So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. And there's your new triangle. We could have also gone down and over. So you could have had a triangle down here as well. But either one of those answers would be correct. So there's your new triangle. Question 5. Triangle TUV. So we have TUV is similar, so same shape, but they are different sizes, to triangle XYZ. So I'm going to make some dots up here at X, Y, and Z. Hopefully y'all can see those letters. Yep. So it wants to know which of the following statements is true. The slope of TU is equal to the slope of YZ. Here's TU. So that is a vertical line which has an undefined slope. If I look at YZ, it's going this way. That is a horizontal line which actually has a 0 slope. So those are not going to be the same. So TU is vertical. which is undefined. YZ was horizontal, which has a 0 slope. So those are not the same. Let's try the next one. The slope of UV, so UV being right here, is equal to XY. The slope of XY. Again, UV is horizontal, XY is vertical. That is not going to be the same. The slope of VT, so VT is right here, this diagonal hypotenuse, is equal to the slope of ZX. So if you notice, this line segment and this line segment are both a part of this bigger line right here. They do, in fact, have the same slope. So similar triangles have the same slope when they are put on a line. All right, that's it for graphs of linear equations. I think I got 2 more videos left. See you in a little bit.